Hello, welcome to this AQA Further Math Statistics video, the last in the series looking at errors in tests involving discrete distributions, and in this video we're looking at a type 1 error for the binomial distribution. So again, just a quick reminder of the definition of a type 1 error, which is when we incorrectly reject the null hypothesis. So our null hypothesis is true, but we end up rejecting it. And if you remember, that can be thought of as a false positive result. We find a change, but actually we've made a mistake because of the nature of the sample that we were using. So let's look at a very simple example here. We're looking at a tetrahedral or a four-sided die that would have the outcomes 1, 2, 3 or 4. And a student wants to see whether it's biased towards the value 1, so more likely to show a 1 than to show 2, 3 or 4. And we're throwing the die 30 times, so our random variable is the number of 1s obtained in 30 throws of the die, and we're going to carry out a hypothesis test at the 5% significance level to see whether the die is biased towards the value 1. So what are our hypotheses going to be for that? How can we set this test up? So if we're seeing whether it's biased towards the value 1, then obviously our null hypothesis is that that is not the case. There is no evidence of change from what we'd expect, which is that the die is unbiased. So that would be P, the probability of obtaining a 1 is 0.25, and our alternative, if it's biased towards the value 1, would be that P, the probability of obtaining the result 1, is greater than 0.25. And this is a one-tailed test, and we're carrying this out at the 5% significance level. So how are we going to find the probability of a type 1 error? So this is our setup for the test. Our random variable, the number of 1s obtained, is clearly following a binomial distribution where n is 30, and from our null hypothesis P is 0.25 if there is no change from what we'd normally expect. And we need to work out the probability that we incorrectly reject the null hypothesis. So P indeed was 0.25, but because of the data that we obtained, we end up making the decision based on probability that we're going to reject the null hypothesis. And so for this one-tailed test, in order to reject the null hypothesis again, we need to find our critical top tail. And therefore we need to find the minimum value such that the probability of getting that value, or something more extreme than that value, is less than 5%, our significance level, when our random variable follows a binomial distribution, n is 30 and P equals 0.25. So what's our extreme top tail in this particular circumstance? Now if we have a look here on GeoGebra, you can see that if we find the probability of getting 12 or more, and of course you can do this easily on your calculator, it comes to just over 5%, 0.0507. So actually we cannot have 12 or more as our critical region because that's greater than 5%. But if we go from 13 upwards, so if the number of 1s obtained is 13 or more out of 30, that probability is indeed less than 0.05. And so our critical region, the outcomes that will lead us to reject the null hypothesis, are 13 up to 30 number 1s obtained when throwing that die out of 30 throws. And so the probability of a type 1 error is obtaining 13 or more 1s when in fact H0 is true, and the probability of obtaining a 1 is in fact 0.25. And that probability is small, it's 0.0216. And therefore we can say that the probability of a type 1 error for this particular test is 0.0216. And remember, this will always be, for discrete distributions, equal to, which is very unlikely, or less than the significance level for the test. And remember also that the probability of a type 1 error is sometimes referred to as the actual significance level of the test. So you might want to pause just for a moment and read this through. This is a scenario where we have a two-tail test where we are throwing a coin 30 times and looking to see how many heads we've got, counting the number of heads, and we're trying to see whether our coin is biased. So it's probably worthwhile pausing and just reading that through and thinking how you would set that test up. So if we look at the probability of a type 2 error for this scenario, our test is going to be that the coin isn't biased, so the probability of obtaining a head P equals 0.5, or it does not equal 0.5 because there's a two-tailed test here. And remember, with a two-tailed test, we split our critical regions, our extreme regions, where we're going to reject the null hypothesis, so that we have 2.5% or less likelihood at the low end and 2.5% or less likelihood at the top end. And because our type 1 error is that we reject the null hypothesis when in fact the probability of obtaining a head is 0.5. So what are the probabilities for our reject tails, our very unlikely low values and high values? And just as before, we are going to need a maximum value at the low end, so the probability of obtaining that value or less is equal to or less than our 2.5% at the low end of our 5% significance, and also a minimum value at the top end, so the probability of obtaining that or something greater than that again is less than 0.025, where we're going to assume the null hypothesis is true and the probability of obtaining a head is indeed just 0.5. The coin is not biased. So again, having a look, this is from GeoGebra, but you can use your calculator easily to work this out. If we look at the probability that x is between 0 and 9, so less than or equal to 9, that is 0.0214. And if we go any further, you can see here we're going to exceed our 2.5%. So our lower extremely unlikely tail is between 0 and 9. And similarly, and notice the symmetry here, because under the null hypothesis P is 0.5, our top end of unlikelihood is 21 to 30. And again, that probability 0.0214, and we can't go down any further because we'll exceed our maximum 2.5% in each tail. And so we end up with our values for rejection as between 0 and 9, with probability 0.0214, and our extreme high-end values 0.0214. Again, keeping that under the 2.5% for our two-tailed test. And so the probability of a type 1 error for this particular test will be the sum of those two probabilities, so 0.0428. And that concludes this series of videos.